Now we will represent the HCDA Lab Chapter 8 WAN technology. We have another lab. We already represent Lab 1, HDLC, and the PPP. Now we will represent the Lab 2, which is the Free-Relay, but only back-to-back connectivity. The topology is like this. We will set up Free-Relay on those two links. Um, the first representative is the on the between R1 and R2. We will set up the free relay, and also we will use the static map to map the local DLC to the remote IP address. I will show you here. 0, 0, 0, 1 link protocol free relay. Yes. And the interface 0, 0, 0, 0, 1 link free relay. Yes. Now we configure the link protocol free relay. Um, the one thing we need to keep in mind is the on the free relay interface, if it's back to back, you have to configure one side as the DTE and the other side as the DCE. Let's see, we don't do that yet. Let's see if we shut to shut display interface 0, 0, 1. See the status is up and down, right? So we have to say on one side we have to say frame relay interface type DTE, and on this side we have to say frame relay interface type DC. So display still down. Now it's up and up. The display interface 0, 0, 1. Now it's up and up. So just keep in mind, less but you cannot ping because we don't configure the layer 2 to layer 3 map yet. It's just like a kind of on the WAN on the line interface. Remember, we need to do ARP. We need to know the MAC address to match the IP address. This one is very similar, but this one the layer 2 is not a MAC address, it's DLCI number. So on one side we will see free relay DLC number 102, and we map. We have to free relay map IP. So the remote IP is 10.0.12.2. The local DLC is 102, and map IP 102, and we have to put the broadcast parameters after this, because if you don't have this, the RIP wouldn't work. This one just tell the frame relay you need to carry the broadcast traffic as well. So on this side, we do the same thing. Frame relay map IP 10.0.12.1, which is the remote IP. Local is 102 broadcast. Just keep in mind that DLC number is only local configured, which means the 102 here is different from the 102 DLC number here. Now we can try to pin 10.0.12.2. Now it's pingable. We can display frame relay map information. You see here, the DLC number is 102, the IP address is 10.0.12.2, and also you can see that's DTE. Let's see on this side, display frame relay map. You see this one is DCE, we set it up, and the DLC 102 IP address 10.0.12.1 is the R1's the IP address, and the status is active. This map is very similar to the to the ARP. We will represent later on the frame relay side. It called the in ARP, and so it will automatically map the local DLC number to the remote IP address. So now on the interface 00002, which is interface between R1, R2, and R3, we configure link protocol frame relay. Yes. Frame relay interface type we call DTE. So here we set a link interface 002 link frame relay. Yes. And the frame relay interface type DCE. So DTE and DCE and so interface so the interface is up and up. But if you ping, you wouldn't ping because you don't have the that DLC2 IP address. So we can say frame relay in ARP. So frame relay in ARP. So let's see. Let's do this. Display frame relay map. Display frame relay map. No, I don't see it. So we forgot to configure the DLC 203. That's it. Now as we display map, you can see the IP in ARP, and here if you display, you should see two. One is the we statically configured for R1, and one is the in ARP for R2. Okay, now you can see it. So this IP in ARP 10.0.23.3 and active DTE DCE. Okay, so we can ping 10.0.3.2. Okay, that's why it's working. Now the let's see the routing table. So you see here, if we run the frame relay on the between R1 and R2, uh, so you can see here. Actually, you learn class for subnet 10.0.0/8 instead of the specific like 10.0.22 or 10.0.23.0 because the RIP they do the automatically summarized. So what we can do here is you can go to RIP and you can see undo summarize, and on this side you do the same thing, RIP, you undo summarized. Now you can display, you can now you can see 10.0.2.0 and 10.2. I mean 10.0.23.0 because we let's see the and the RIP we disable the auto summarized. So keep in mind for the frame relay configuration, frame relay plus RIP configuration. If you don't see the specific route, you have to disable the summarize. Another thing is remember when we configure we have the broadcast here, right? Let's see if we don't have this parent, what happened. So interface 00001. Now we disable. So let's see the config. Okay, now we don't have it, and let's. Oops. Okay, now we have to from name map IP 10.0.12.1.102, but we don't have the broadcast. So if we display from the interface display IP route, here we don't learn any routes anymore because the two router doesn't exchange routing information. Display IP. Okay, so now when we show the frequently map information under the interface, you see there's no summary here. So that's why you cannot exchange the routing information. You see here. The solution is and the RIP. You can see peer 10.0.12.1, and here again the RIP. You can see peer 10.0.12.2. What happened here is you specify your RIP pair, and it will use the unicast instead of multi. Now you can learn the instead of the broadcast, so you can learn the routes now. Yeah, and you should be able to ping 10.0.2.2. Now we will configure the OSPF between the R2 and R3. So we set up router ID 10.0.2.2. So here the router ID is 10.0.3.3. So we have OSPF1 area 0 network 10.0.0.0 23.0.0.0.255. So here OSPF1 area 0 network 10.0.23.0.0.0.255, and also network 10.0.3.0.255. Okay, now this IP route table, there's no OSPF. There's no OSPF. Why is when you show OSPF interface 002, you can see the type is NBMA. OSPF interface. You can see the type is NBMA. And if you show peer, you don't see the peering. So what we can do is end the OSPF. You can see peer 10.0.23.3, and you can see peer 10.0.23.0.23.2. Now if you see OSPF peer, you can see the peer. You can see your neighbor, and you should be able to display OSPF peer. So on the IP routing, so now you can see you learn 10.0.33, and you should be able to ping it 10.0.3.3. That's one solution to fix this problem. And another one is so if you undo, what's the peer? Do peering. It's waiting for the die timer, so we just undo lost your pair again. So another thing is you can change the end of the interface. You can change the OSPF. Uh, OSPF network type broadcast. OSPF network broadcast. The OSPF peer. Now you got the peer back. And if you display your OSPF interface, you see the type is broadcast because you display IP route. It's not there yet. Now you should learn it. You see here they say the neighbor is full, which means they establish the pairing. In this lab, we learn how to set up the back-to-back frame relay and end the back-to-back frame relay. If you configure RIP, you have to remember the um, one thing is the if you run RIP, uh, sometimes they may not be able to exchange because when you configure the frame relay map, the DLC and the IP, you have to add that broadcast parameters there on both sides. Otherwise, if you don't have that one, you have to under the RIP you can see peer. You have to specify the peer. The OSPF with the frame relay is some similar situation. Um, you have to either change the network type under the interface, or under the OSPF you have to specify your peer. Um, so that's the two things you remember. You have to remember because the frame relay encapsulation is different from the PPP and the HDLC. Um, you have to map either manually or automatically use the in-app to map the local DLC number to the remote IP address. That's for lab 2. Thank you for